The sequence 2, 6, 10, 14, 18. Observe that this is a sequence of positive even numbers, and each of the pair of numbers differ by 4. 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14, and 14 plus 4 is 18. This is the property of linear model. The constant rate is what we call the slope m. M is 4 in this case, and the initial value in this case is 2. The linear equation model is y equals mx plus b. In this case, m is 4, and the initial value is 2, but only when x starts with 0. So we can use the formula a sub n equals 4n plus 2 for the n term in this sequence. We can check that when n equals 0, we have a sub 0 equals 4 times 0 plus 2, which is 2, the first term. When n is 1, we have a sub 1 equals 4 times 1 plus 2, which is 6, the second term. When n equals 2, we have a sub 2 equals 4 times 2 plus 2 equals 10, which is the third term. Now, if we insist that n start with 1, then we simply shift this model or formula 1 unit horizontally. And so a sub n is 4, and we would move n to the right 1 unit. This formula is now 4n minus 4 plus 2, or 4n minus 2. But only when n start with 1. So for example, for n equals 1, which is the starting value, a sub 1 is 4 times 1 minus 2, which is 4 minus 2 or 2. So that checks out. A sub 2 is 4 times 2 minus 2, which is 8 minus 2 or 6. That checks out. A sub 3 is 4 times 3 minus 2, which is 12 minus 2 or 10. That checks out as well. And again, the formula for a sub n is not unique. Not only they are different depending on whether we start at n equals 0 or n equals 1, but any formula will work as well as long as it represents this sequence. The sequence negative 3 over 2, negative 1 over 6, 1 over 12, 3 over 20, 5 over 30, and so on. This is not an alternating sequence because the signs do not alternate. Observe that in the numerators, there are consecutive odd integers. Negative 3, negative 1, 1, 3, 5. It is true that the formula for the odd integers are 2n plus 1, but 2n plus 1 will not work in this case because when n equals 1, we would have 3. We would start at 3 instead of negative 3, but we can change this formula. We can shift n to the right by 3 units so that we can start with negative 3, and to do that, we simply replace n with n minus 3. This is 2n minus 6 plus 1 or 2n minus 5, and we can check this. If we start with n equals 1, then 2 times 1 is 2, 2 minus 5 is negative 3 in the numerator. And then when n equals 2, 2 times 2 is 4, 4 minus 5 is negative 1. When n equals 3, 2 times 3 is 6, 6 minus 5 equals 1, and so on. So the formula for the numerator only is 2n minus 5 when n start with 1. In the denominator, observe that we have 2, 6, 12, 20, 30, and so on. And by observation, we see that 2 is actually 1 times 2, 6 is 2 times 3, 12 is 3 times 4, 20 is 4 times 5, 30 is 5 times 6, and so on. So in the denominator, the formula that works for these is n times n plus 1, the product of two consecutive integers, assuming that we start with n equals 1 as well. So we have a formula for both the numerator and the denominator. Therefore, the sequence a sub n is 2n minus 5 over n times n plus 1 for n starting with 1.